Welcome back to the third iteration of my R short series, Linear and Multiple Regressions. In today's video, we'll be going over how to feed your data into a linear model, and more importantly, how to interpret the results that come out. Now, as usual, we'll be using the Palmer Penguins dataset. So let's go ahead and load all of the packages that we need. So the first thing we're going to be using will be the tidyverse. We'll be loading up the Palmer Penguins. We'll be bringing in the data of the dataset penguins. We will also be using Psych. So again, if you do not have Psych, do go ahead and install it with the install.packages function. And one more thing we'll be doing that will make our interpretation a little easier is removing scientific notation by using the options SciPen. So let's go ahead and run that. So the reason I'm using options SciPen is to remove all scientific notation from when we get the summary of our linear regression, because if we don't, we'll get these constant values of E, and it makes things look a little muddy. All right, so let's load up penguins. Okay, so first thing is first, as with the last video, we'll be using the pairs panel function from the Psych package. And the reason we're going to be doing this is to look at some obvious relationships in our data so that we can figure out what we can correlate together using the linear regression. So let's go ahead and run this. There we go. Okay, so let's zoom in. And today I'll be focusing in on flipper length, build depth, and build length. So again, flipper length is down here, build length is here, build depth is here, sorry, and build length is here. So if we take a look at flipper length and build depth, we see that there's a somewhat strong negative relationship. And if we look at flipper length and build length, we see that there is a somewhat strong positive relationship. Okay, great. So let's go ahead and confirm this relationship using ggplot, and then we can move ahead with our linear regression. So let's use ggplot. The data will be penguins, obviously. The first aesthetic we'll be using will be build length in millimeters, and then I'll be doing a dot plot. You can do a line graph if you want. It should give you roughly the same idea. And here the aesthetic will be flipper length in millimeters. And just because I like it, I'll be adding the classic theme to it. And let's run this. Great. So what does this tell us? Yeah, it tells us that build length and flipper length seem to have a pretty strong linear relationship, and that, it kind of confirmed what we saw in the pairs panels, and we can move forward with a linear regression. So let's go ahead and do that. So doing a linear regression in R is actually very straightforward. Interpreting it is something a little different, but we'll get there. So the first thing I'm going to do is name my linear regression. So I'm going to name it penguins.linear.regression, and then all you need to do the linear regression is LM, the LM function, which stands for linear model. And then the first thing you want to feed it is the variable you are trying to explain. So the variable that ends up on the y-axis. So in this case, it is flipper length in millimeters, and then you want to use the tilde sign, and then feed it the predictor variable, which in this case is build length in millimeters, and then tell it what data set you're using, which obviously in this case is penguins. And then to get a summary of what the model looks like, we use the summary function, and we tell it to summarize the penguins linear regression we just made. So let's go ahead and run this, and now we get this output down here. Great. All right, so the first thing we're going to look at is the residuals up here. And these tell us basically how well the line fits our data set. And so if you see you have a minimum, a 1Q, a median, a 3Q, and a maximum, And basically what you want is all of the data, or all of the numbers, to be roughly symmetrically distributed around your median. Now in this case, 1Q and 3Q are more or less identical, but minimum and maximum do show a little bit of variability, but those they're a little less strict on how evenly distributed they should be, so this should be fine. Down here in the coefficients, really what we're interested in is only the build length in millimeters. And for the sake of this video, the only thing we are actually interested in is this part here, which is the p-value. Now, I'm not going to go into too much detail on what a p-value is or what a t-value is, but what you should be concerned about is whether or not this value is less than 0.05, which in this case it obviously is. Great. Now let's go down here to the residual standard error. And what we're interested in is the multiple r-squared value and the p-value associated with it. Now, again, we want a p-value of less than 0.05, which we do. And now we can go ahead and interpret the multiple r-squared value. So we have a multiple r-squared value of 0.43. What does that mean? Well, it means that bill length accounts for 43.06% of the variability, almost 50% of the variability in flipper length. And that is how you do a linear regression in R and interpret the results. I'll be splitting this video into two parts. The first part is the linear regression portion, and the second part will be the multiple regression portion, just to keep it in theme with the R short series, because this video is already getting a little long. So if you're interested in learning about multiple regression, just follow the link in the description to watch the next video. I hope you enjoyed it.